Anyways, my name is Kyle Owen. You're probably here to listen to a PDP-8 and not me, but anyways, just a little background. I got started with vintage computing when I was in junior high. Someone gave me a Southwest Tech 6800 that had a New Tech Model 68 sound card, little 6-bit DAC, little speaker. And I reached out to Mr. Neufeld, and he said he could not help me. He no longer had the resources to help me with this 1970s sound card. So anyways, I eventually found someone who did have the software, got the entertainer playing, and that just became the start of computer music for me. And I upgraded to a 12-bit PDP-8 somewhere along the way and decided that, there was a program written to make it play music over the AM radio, so that would be one of my goals. I've also upgraded it with some new hardware that I'll show you in a little bit. But with that, let me just try and get this thing powered up and see if it still runs. Who here has a PDP-8, by the way? Absolutely. Hands are a lot quieter on this model. A little nervous at first there. So first thing I'm going to do is load up the bin loader, and I'm going to load a program. Actually, I'll tell you what. We'll start with loading up OSH. Who here remembers the RK05 bootstrap? Doug? Yes. 6, 7, 4, 3. Deposit. 5031. Okay. Address. And sorry, we just stopped. Sorry, very quick. This is also a good time to show off. This is a RK05 emulator made by George Wiley. This weighs considerably less than an RK05. Who here has picked up an RK05? Who knows what an RK05 is? 2.5 megabytes, weighs 120 pounds. I quite literally got a hernia. I'm not going to show you my scars, but I did take one up the stairs and deeply regretted it. So this one is a lot easier to carry to shows. So it's reading a file off of the SD card, loading it into memory. It's got a lattice FPGA and a pipe decode inside. And you can daisy chain these together as per the original RK05. I've got the original controller of the PDP-8. And so anyways, we should now be able to hopefully boot. Sorry, y'all. That's really disappointing.
It happens to the best of us.
Given that I have 20 minutes, why don't we just chat? This is a custom designed PDP-8 synthesizer. This sits on the Posibus. Now, the PDP-8 started life in 1965. It was a negative logic machine. Logic voltages were -3 and 0 volts, which sounds really foreign to anyone. Today, you see TTL and 5-volt logic. But Back in the day, everything was using discrete transistors, diodes, resistors, and capacitors on small flip chip cards. And Vince Slingstad here has a website that talks about every single flip chip known to man, with particular emphasis on the 12-bit machines. But a lot of people have not given any love to these older machines in terms of creating peripherals that are interesting and unique. And these peripherals are very hard to come by. You can get a TCO1 deck tape controller if you're really lucky, and you can get a RF08 hard drive and all these other stuff. But they're very hard to come by, very expensive. And so what I wanted to do was kind of lower the cost of entry. And I thought, if I'm going to experiment with using the Posibus, which is the same as the Megabus, except Posibus uses 0 and 3 volts instead of 0 and negative 3 volts. So it was quite easy to interface with a modern CPLD. Modern, of course, being relative, because this is still, for those that know, an Altera Max 5, which has been around just a few years now. And I'm sure right as soon as I get ready to design the next board, it will be discontinued, as they do with so many of their CPLDs and PDP-8 these days. But what I've designed here is the main board has a single CPLD, voltage regulator, MIDI input and output with the optical isolator and all. Power supply is confined to here and one tiny regulator on the back. And then these cards right here are my bus interface cards. Now, I talked about how the logic voltages are 0 and 3 volts on the bus, but just to be very sure, I have some diodes that will drop that voltage on any of those open collector lines to a safe 3 volts. And then I have MOSFETs that are capable of pulling those lines down to ground. So that is its own little daughter card that plugs in. That way, if I want to design a Megabus interface, all I have to do is design one tiny card. These cards were $4 for 5, so they're kind of cheap. The big board is 4-layer, and I think it was $40 for 5. So still, this is JLC PCB, and if I had someone in the States that could get a week turnaround at the same price, it would be no-brainer. But unfortunately, I don't know of any board houses in the U.S. that are offering such an inexpensive and quick turnaround. So the DAC boards are the most expensive in terms of parts, because we've got $7 DAC, which is a parallel load dual DAC, and I'm able to series these 2 DACs so that I can have full envelope control for every channel. I can also reconfigure it with a set of 5 jumpers so that I have 2 independent DACs, and that way I can actually have up to 24 channels. To talk a little bit about the Verilog that I've synthesized for the CPLD, it's just maybe a couple hundred lines of Verilog at that. It implements what we call in the PDP-8 world data rate, which anyone else would know as DMA, direct memory access. So in order for this to be a PDP-8 synthesizer, I really wanted to use wavetables stored in PDP-8 memory. If I had its own memory on this board, I just feel like the PDP-8 would be doing so little as to really not be able to call this a PDP-8 synthesizer. So a little bit more about the architecture. I've got a timer inside the CPLD that I can set for the sample rate. So for instance, 20 megahertz clock, I can divide by 1,000, have 20 kilohertz sample rate. At every timer tick, the CPLD asks the PDP-8 for a succession of 12 samples from memory. And where you are getting those samples in memory, there are 12 24-bit phase accumulators. So because this is a wavetable synthesizer, one of the easiest constructs is to simply add a known phase every cycle. The greater the phase angle that you're adding, the faster you will traverse your waveform, the higher the frequency. So I have very easy program control over the high 12 bits and the low 12 bits of the phase accumulators. and I can do that on a per channel basis. And then in order to set the envelope, that is done simply with a 12-bit value written directly to the back. So right now there's no easy way to do attack decay and all of the fun normal synthesizer stuff except via software. The software is very limited right now, mostly because I was lazy and feeling uninspired. And also because I was building this until 12:30 2 nights ago. But it turns out through-hole components are really time-consuming to solder, especially when you have 14 32-pin headers plus 5 40-pin headers plus all of the little ones on the little daughter card. So some of my lessons learned will be to stick with surface mount headers if possible. I did not have access to a running pick and place machine at the time, so I used tweezers to place all of the tiny components. And anyone's welcome to come see up close here afterwards. We'll just forget ESD existing. So hopefully the CPLD is not too ESD sensitive. The total cost of this is still currently unknown because when I go on DigiKey, I always buy up to the next price break, which probably tripled my cost, but hey, at least I have spare components. And maybe there'll be one other person that expresses interest in owning one of these two, so I can link you up with some parts for the cost. But I've got 4 mixer buses that I can select any of the outputs to flow data, flow audio out onto. I've got 2 dual mixer cards here at the end with the 3.5mm jacks, and then I didn't populate them because, again, through all components at time are soldered, but I do have discrete audio output from every DAC channel as well. So if you want to go to your own mixer, that is totally possible. But this, I think, is going to allow me to pave the way to creating other positive bus peripherals. I've got a tested design for a TC08 deck tape controller. And I'll just briefly talk about some of my other ventures. So Vince, if you'll wave your hand, Vince, as I mentioned, he's kind of one of the major web presence for PDP-8 stuff online. He has taken a lot of time in his retirement to digitize very painstakingly deck schematics, including the PDP-8i, the 8L, the 8S, and everything except the 12, which I'm still begging him to do at some point. But it's several hundred pages, and who's got that kind of time, even if you are retired. So, anyways, the project that I worked on with him a couple of years ago was to take his Eagle schematics, export a netlist, take that netlist, translate it into a Verilog netlist, and then I would manually write a Verilog description for every single module that would go into the backplane of a PDP-8i. And I figured if Vince's schematic is correct, and the netlist is correct, and my testables, tiny modules of every flip chip is correct, then you should be able to synthesize all that together and have a perfectly cycle-accurate PDP-8i. Turns out you almost can't, because there are things about the 8i and many other machines from this era that don't translate well to, they do some circular logic, and you end up having to add like a little register there, right? So, but after a little massaging, the design was tested. We now have a synthesizable PDP-8i code. This is not the first PDP-8 synthesizable for an FPGA. It is the first to be totally 100% accurate to DEC, and I'm hoping that I'll be able to have a hardware version hooked up to this instead of lugging my 3-rack PDP-8i system next year to the show. So, with that, I also took the schematics for the TC01 and TC08, which are the same exact design, other than one is implementing negative logic, one is positive logic. And so, hopefully, with this CPLD proven as a nice unit, much many more logic elements than I think a lot of people are using the ATF-1508, which is a clone of the MAX 7000. And then some of the Atari guys and others are favoring that. It's now entering into obsolescence, so very sad. At least the 5-volt version, and maybe 3.2 volt policy. But hopefully, with a little effort, this same kind of design can be made into a TCO8. And for those that have not seen a TCO8, it does come with a big front panel with blinking lights, and I figure anyone recreating it will also be forced to recreate the blinking light display, otherwise, why would you have it? So, but anyway, stay tuned for next year. Maybe something will cooperate and we can better hear some music. I do have some videos on YouTube and on my phone, and I regret that I can't show you in person, but anyways, I'll take some questions and maybe let y'all get out here early for this disappointment.
Would you talk about the audio capture?
Sure. So Crawford got to witness this running. He is one of maybe 5 people in the world that have heard this. But one of the projects I have not talked about was with the RKO5 emulator. The RKO5 emulator does not make any attempt to characterize the seek time of a hard drive, right? So if you seek from one end of the disk to the other, it takes the same amount of time for stuffing and track of it. As a result, I figured, based on the bandwidth, there should be a means of being able to play back samples in quick repetition. Perhaps you could take any sort of music that you enjoy and actually dump it onto a RKO5 platter, or in this case an SD card, and play that back at some sample rate, maybe even up to 16 kilohertz. And because Vince created a recreation of the VC8E, which is the oscilloscope interface, we call it the point plot display in the PDP-8 world. It's got 2 DACs, 10-bit DACs. That's not quite audiophile grade, nor is 16 kilohertz, nor is monophonic, but we were able to get some Boston playing, some ELO, all through a PDP-8, something that I don't think has ever quite been done and may not ever be done again. But anyways, so yeah, we have the ability to stream. I think with 16 kilohertz, approximately 1.5 minutes worth of audio off of the full disc. I figured that would have been a very expensive way to listen to music back in the 70s. But the interesting thing to note is I'm not doing anything with that project that could not have been replicated 50 years ago. Likewise, I know I'm using a CPLD here, but this could have been one giant 19-inch rack of flip-flops, right? There's nothing here that I'm doing that could not have been done 50 years ago. So, to me, it's a little interesting to think what could have been done if you had the $20,000 to spend on 7400 series logic back in 1972 or so. Any other questions? Maybe I'll get it running out in the show and it's just, maybe the voltage is too low for the stupid extension cord.
What song were you going to play?
All right, so great question. One of the songs was Sea Shanty 2 from RuneScape, which I regret. Yes, the Maple Leaf Rag was one that was written back, arranged for this back in 1974. Sea Shanty 2 was arranged by me a few years ago. I also have Popcorn that I arranged for it. And then it actually is a very basic MIDI synthesizer now. So any MIDI song can technically be played through the 12 channels here. And because it's a wavetable synthesizer, you can hopefully create 74 or so that music program was written. That uses only the PDP-8, no additional peripherals. That was through a basic interface described in the DECUS listings. So DECUS was the Deck User Society. In the DECUS 804 listing, they talked about how you could add a monostable and a little low-pass filter to output it to an amplifier. So you were listening to the high-quality audio version rather than the AM radio version, but both are recognizable. So, thank you. D9, okay, D9. So anyways, feel free to come hang out. Maybe you'll hear it in another 30 minutes or so.
Thanks.
Any other questions? I think we've got 2 minutes, so. Hey.
What's the power usage on that?
The power usage?
Yes.
I don't know, 400 watts. I don't have core memory in this model. Vince built a 32K solid state memory board that uses way less power. It was battery backed up, so it's like core memory, but a lot cheaper and a lot more reliable. Doug, however, believes in real core memory. So if you want to see real core memory, come see his AE that's also out there.
Yeah, that's been
No, he's leaving early. So.
next year.
All right, one more question. All right, you got one, Rob?
Yeah, what voltage is for the CPU?
The Max 5 is a 3.3 volt IO, 1.8 volt core voltage. And this whole thing takes like 200 milliamps. So it does save a lot from giant rack TDL.
And how are we going to get home?
Exactly. All right, thank you.